All right, we're about to tackle a math problem that, on the surface, looks like it would make a supercomputer sweat. But what if I told you there's a hidden shortcut, a way you can solve it with just a pen and paper? Let's dive in and break it down.
Okay, so here it is. Take a good look. 2 to the power of 18 minus 1. I mean, without a calculator, that seems kind of impossible, right? Just imagine trying to calculate 2 times 2 18 times in a row. You'd be here all day.
And yet, honestly, your first instinct is probably right. This just isn't practical to do by hand. The numbers get absolutely massive, super fast. It almost feels like a trick question, like it's designed to be way too hard. But here's the cool thing about problems like this. They almost always have a hidden structure. There's this elegant pattern just sitting there, and once you spot it, boom, it completely changes the game. See, this isn't about brute force. It's about finding that one clever path. So here's our first big aha moment. Let's look at that exponent, 18. Instead of thinking of it as just 18, what if we see it as two smaller numbers? Like, 9 times 2? It's the same thing, right? But this simple little change lets us rewrite the whole expression as 2 to the power of 9, all of that squared. The value is exactly the same, but the shape of the problem, that's completely different now. And this is why that little change is so important. By turning it into something squared, we've basically set the stage. We've unlocked the door to use a classic, super powerful tool from algebra, something you probably remember from back in school. And that tool is the difference of squares. This is our master key, the secret weapon for this whole problem. The formula is simple, right? It just says that anytime you have a squared minus b squared, you can instantly break it down into a plus b times a minus b. It's one of the most useful shortcuts in all of math. Okay, so check this out. Our problem fits this formula perfectly. Our a squared part is that 2 to the 9th squared. So our a is just 2 to the 9th. Simple. And what about our b squared? Well, 1 is the same thing as 1 squared, right? So b is just 1. It's a perfect match. This is our way in. All right, so we've got the lock, we've got the key. Now let's put them together and watch this impossible problem just fall apart. Okay, so we take our expression, 2 to the 9th squared minus 1 squared, we plug it into the formula, and instantly it transforms. It becomes two much simpler pieces, 2 to the 9th plus 1 multiplied by 2 to the 9th minus 1. So much easier.
Just look at that. We've totally sidestepped that massive, scary calculation. And now the whole thing boils down to a much smaller question. What is 2 to the power of 9?
And that's a number we can actually work with. 2 to the power of 9 is 512. And hey, if you've ever worked with computers or video games, that number probably rings a bell, right? It pops up all the time with memory and data storage. So now we just plug that 512 right back into our two pieces. So 2 to the 9th plus 1, that's now 512 plus 1. And 2 to the 9th minus 1, well, that's just 512 minus 1. See how easy this is getting? And just like that, our original monster problem has been tamed. It's now just 513 times 511. I mean, that's a huge win already. We're almost there. But you know what? We can make this final step even easier. So how do we solve this last multiplication without a lot of fuss? I mean, sure, we could do long multiplication, but why would we? There's a much cooler, more elegant way. Let's break these numbers down one last time. What we're going to do is split each number into a nice round number and whatever's left over. So 513 becomes 500 plus 13, and 511 becomes 500 plus 11. This structure, oh man, this is perfect for doing math in your head. All right, let's multiply this out piece by piece. First, the easy part, 500 times 500. That's a clean 250,000. Okay, now for the middle bits. We've got 500 times 11 and 500 times 13. Let's just combine those. That's 500 times, 11 plus 13? 24. 500 times 24 is 12,000. Got it. And last, we just multiply the leftovers. 13 times 11 is 143. See? Each of those steps, totally doable. Okay, home stretch. All that's left is to add up our three chunks. We've got 250,000 plus 12,000 plus 143, which gives us 262,143. And there it is. We did it. We took a problem that looked completely impossible, and just by finding its hidden pattern, we solved it with a few simple, logical steps. No calculator needed. And the big takeaway here isn't just the number.
It's the idea that a problem that seems totally overwhelming at first can often be cracked open with just one simple, elegant insight. It's really not about working harder, is it? It's about working smarter.
So that kind of leaves me wondering, what other impossible problems out there are just waiting for the right, clever shortcut to make them fall apart? Something to think about. Thanks for joining me.